This is the brief introduction of the ADT and problem solving on queue and linked list. Okay, so this will be talk about the concept of queue and then the implementation of the queue and also the linked list. So for queue is like when you have a queue at the restaurant, and then the concept is the same thing. So when we add the element to the queue, so here is the first guy and the last guy have come to the back or to the rear. So for the queue is will be first in and first out. So the people who come first and going to the queue first as well. Okay, this is like coming first and going out first. So it will be first in first out of V4. Okay, the item that you're gonna start is will be on the back and the front. Okay, so when we remove the element, or we call it a DQ. D is delete. Okay, so DQ mean delete the item out of the queue. But if you would like to add the new value, this will be add to the back. Okay, and this is example of the queue operations. Applications that we can use is like when you are at restaurant and then we get something in the queue, and then once you are called, then the first people come first will call first. Okay, so this can be applied to like grocery store, gas stations, or anywhere that they have a waiting in a line. So here is the important terms that you guys need to know, like font, where, NQ and DQ. N is enter. So this is to enter the new data into the queue. DQ, D is like a delete, so we remove the data of the queue. So when we DQ, it will be DQ from the front of the queue, but when we NQ, we will add the data into the rear part of the queue. Okay. Alright, this is how we can use array based and linked list based to queue implementation. Actually, here you can use the array or linked list or stack to like be as a queue. Here is just the array, and you need to have like a front and back positions, and then you need to like see where is the front and where is the back. So you see 0 here and 3, so it's the value of front and back, and here is the value of front and back here as well. And what we're going to do in the stack, as you know that stack has some drawback that we need to fix the size of the stack. So when we use it, when we like pop it, when we DQ, so some part here is gone, and then the pointer from the front is moving this way. That is why front is start changing from 0 to 47, and max q is equal to the last minus 1. Okay, so it will be the index array that we can apply as a stack, but yeah, there's a problem. Like after we DQ all of this item, then how we can use this space that you already allocate but no used. We can also use the linked list, which head point to the front, and then the rear is pointer here as well. And then you can also get the number from front and rear, like 3 things, and the last one is connect to the ground. And we can also use NQ and DQ by using stack as well. We'll like pop and push. And here is how is this, like when you use the array based queue, the front one will be the one going out first for the DQ, and the people who would like to add into this queue will come from last. Okay, and that is 2 pointer. One is front, which is point to the front one, the front value, the first value, and the rear one is like the one that like the last value that you could just add into the array based queue, and this is the last position is called as a max queues. So here's the list of the operations which can have NQ, DQ, front is empty, size. So NQ is like add 5, add 3, DQ show 5, means the front one DQ first, add 7, return 3, show the front value, which is 7 at the front pointer, and DQ 7, then you cannot DQ anymore because there's no more any value in the queue, and you check is empty, then they return through. And then you NQ the number again, it's just 9 and 10 into the queue, and then you check for the size. They will return like getting the front and the rear one, and get the difference between these two positions. Then you will get the size of the queue, and then you can NQ 3 and 5 back to the queue like this. Very simple. So the operation is, one is just to create the empty queues, right? The way we calculate is just one by one, so O is just O1, and check that is it empty or not. How we can NQ, how we can remove the queue from the first one, which is NQ. This is DQ, right? The earliest one is the one in the front, or we would like to remove all item from the queue. Okay. So here is like things that we can do. Create queue, NQ5 to 7, and then get peak. Get peak, which is the 5, which is the peak value, and UDQ, then 5 is the return, and UDQ again is to go with the return. Okay, Q, DQ. So for the LA based, somehow they will have some problem, like when we add the item into the queue, the LA. So what you need to do, you need to define the front and the rear index. Okay, so when we would like to NQ means add, so you need to add change the position of the rear index, because you need to add something to the back one, right? But there is nothing moved from the front. But when you DQ, the last index will not move just only from the front, because you will DQ from the front, right? So when you DQ, this position change, right? This position doesn't change. But when you NQ, this position change, this position doesn't change, just that. Okay. So here is just an example that we have the position of the front, rear, and length. So first they point out at this position. When you add join here, the first position is point 0, the rear is point 1, the length is just 1. And then you NQ mend. The first position is start at 0, but the rear position is extended to 2. So it means that they added a value. Okay. And when you NQ again, so you can see that this one is changed, right? So it means that when you add the value in the back, so the rear index will change the position. But when you DQ, so something is changed from the front, mean that the first position is moved, the last position is fixed. That's it. Fixed mean like the same thing as here. And this one is just changed from 0 to 1. So the chain is here, and also the difference as well. So how you get the length? This will be 0 and 1. 0, 1, okay, 1 minus 0 equal to 1, 2 minus 0 equal to 2, 3 minus 0 is equal to 3, 3 minus 1 is equal to 2. So you get the length of it. So this is how we can move the first, rear, and the length of the queue. And this one is using linked list. So we can use like front.next and then rear.next to point out to the next node. And then we will create the queues and then set the node for the front and the rear. And then we'll like shaking the node, moving back and forth by shaking .next and go through the elements of that one for NQ and DQ. And another one for the LA based. One thing that we can do is, if it's a circular fractions, what we can do is we can like reuse this area. Just remember, if you already changed the queue, the front is moving this way, right? And this area is this you already reserved the space for the alley for this part, and then one is full, then you cannot reuse this one. But if you make it like this, then you can reuse the position from here. How to do it? It's just using the modifications, getting the modification to get the position of the front and the rear, and then you can like get the positions between F and R. And you can also check that if F and R is at the same position, then it's just empty. And if you would like to get the position of the size of the queue that you have, you just calculate the mod between F and R. That's it. And for linked list is the one that is the linear data structure that we're gonna do. So the component of the linked list is this is how different between array and linked list. One is the size, array is fixed, linked list not fixed. The data is stored, but this one can be stored to any page, but this one have to like connect continuously connected, store together. And linked list for the array, if you would like to insert and delete some position, is very complex because this have to use the index value to access to every single position. But if you have linked list, it will be very easy and simple, and maybe somehow it's faster. Alright, the concept of linked lists is can like connected to anywhere if you know the value and also the pointer. Okay, and you can also remove from everywhere. Imagine if you use an array and you remove this one out, just mean that you need to shift every single value to the like one position ahead, right? So you know there's a lot of things that you need to do. But if you just linked list, you just delete the node that you connected from this node and this node, and then you just reconnect this one back again, and that's it. Just 3 operations. So there's 2 components of the linked list that you guys need to remember. One is the data, second one is the link. Okay, and what we're gonna start here basically is the single linked list, but I'm gonna show you some idea of the double linked list as well, but this is just have back and forth pointer. So here is an example of the single linked list that we're gonna have the head and the ground, and we're gonna have the element, which is the value, and also the pointer, which point to the next value. Okay, this is 4 things. One is head, second is ground, third is neck, fourth is element. So 4 things that you need to know. And that is how it's like linked to the next value. Okay, for the single linked list, head point to this one, head.neck, so point to the next value, next dot next, then next to the next value. Okay. And this one is also showing the linked list in the memory. The upper one is the pointer to the next node and the pointer to the element. So you can see here, if we start from this one, so the upper one is pointer to the next node, this means that the next node is this node, right? And the value of this one is B. So it starts from B, and then the next node is this one, right? 5060. So the value of this one is 50E0. So it's R, right? The value of it is R. And then the position next to the next node is this one, 5080, which represent to the value 50D0. 50D0 is S. And then the next node is point to 5070, so it's this one, and the value is 5110, which is T. So the node is point in this way. Okay, this is from the memory of the linked list. So they will have some operation of the linked list that we can do, like insert, delete. At insert and delete, it can be like insert at the beginning, delete at the beginning, okay, or add the specific positions. Add the data, remove the data, search for the data, find the data, get the size of the linked list. This is what we're gonna do, okay. And here is some example of the student record. So we create the node which is have data and next, okay, and inside the node we will get some information of the student data. So you can see from the student record we can get called as the SR, which represent the student record that we have. So here is the student record data, okay, and in the student record data is name, GPA, and SSN. So what we have is we create the new SR with this structure, and then we will link it with the data and next. So we point data to the information here for the SR, and the next is point the node to this data. And then when we add a new value, okay, when we add a new value which is name Mary, GPA 3.7 and SSN is 987 something, then we create a new pointer, link the data here, and we would like to connect this node together, then we just connect next together here, then we can connect these two nodes together. Got it? Again, we create this data and then map data to the linked list, create another data, map the data to the another linked list which called node 1 and node 2, and after that we would like to connect these nodes together. What we do is point next, so the pointer from the first node N1 point to the next node which is N2. So the pointer will be point here. The code is just create N1, create N2, and then point these two together. Okay. This is the basic idea of the linked list.